All right, so here we're going to try to find, we're going to find cosine inverse negative rad 2 over 2. And I'm going to call this theta and say that this is the same thing as cosine theta equals negative rad 2 over 2, but theta is restricted between 0 and pi. All right, so what I'm going to do is to try to get a handle on this is draw a circle, a unit circle, and see if I can get that a little better. Yeah, okay. And actually, I think what's not good is my lines here. I need graph paper. It's more or less the answer to that one. Okay, so, all right. What's going on is if I'm looking at cosine theta equaling a positive number, I'm going to look in quadrant 1. All right, so I look at quadrant 1 if I want cosine theta equal a positive number. But what here cosine theta is equal to a negative number. What's the closest quadrant to quadrant 1 where cosine is negative? Cosine is negative all the way in quadrant 3, but that's far away from quadrant 1. Right next door is quadrant 2 where cosine is negative. The output of cosine is negative there. So that is my sort of an explanation for why we're going to go from 0 to pi. I mean, this is how they've decided to define cosine inverse, and it's a good way to define it. I think anybody would have done that. So they chose it to be from 0 to pi. It's not the same as sine inverse. In sine inverse, we go all the way down into quadrant 4 where sine is negative. But see, cosine's positive in quadrant 4 also. I mean, cosine's positive in quadrant 4, so that would not be what we want. We want cosine theta equals a negative number. Anyway, always for cosine inverse, the range is from 0 to pi. Okay, there are different ways to look at this. We could think of cosine as being the x-coordinate, and through that we might have, quite possibly have memorized this, and that's sort of what we're supposed to do. So if we remember that when x is rad 2 over 2, or in this case negative rad 2 over 2, y is rad 2 over 2, that corresponds to our reference angle of pi over 4. And if I take pi and I subtract 1/4, I'll get 3/4 pi. And that's therefore going to give us our answer. We could also use a right triangle approach, but I'm going to just call this the reference angle. And I'm also going to write it as 1 over rad 2. And so that's adjacent over hypotenuse. And looks sort of messy there, but so maybe I've memorized this stuff also. And if I have 1, 1, rad 2, that corresponds to pi over 4. So that's how I get the reference angle. But that's not enough to solve the problem, because I have to know which quadrant it's in. So I get the reference angle is pi over 4, but it's 3/4 pi because of the quadrant in which it lies, which is quadrant 2, where cosine is negative. Alrighty, so that's the answer there.